Solving Exponential Equations, Level 1. Today, we're going to continue our work with exponents and logarithms to solve equations that have a variable in the exponent. Let's take a look at the first problem. Solve for x, rounding to the nearest hundredth. 11 times 2 to the 3x equals 1. I'm going to use Desmos' scientific calculator to show all of my work, but you can show your work in any way that you'd like as long as it makes sense to you. You don't need to turn in this work, but I find it very useful to keep track when you're working on problems like these. I'm going to start by copying the problem into my workspace. 11 times 2 to the 3x equals 1. I like putting complex exponents in parentheses when I'm working with certain kinds of calculators. It's just a habit. On my next line, I need to figure out how I can start getting this x isolated. I notice that this 11 is a coefficient. It's 11 times 2 to the 3x, so I can cancel this coefficient by dividing. Divide both sides of the equation by 11, and it cancels on the left, leaving me with 2 to the 3x. And on the right, it's just 1 divided by 11, which I'll just leave as a fraction. Awesome. Next step. Now I have a base and an exponent, and for the most part, it's pretty simple. If I want to get this variable up out of the exponent, I'm going to need to start using some logarithms. Now, knowing that this calculator only does common logarithms and natural logarithms, I'm just going to skip a few steps and go straight to those. I know that I can rewrite this equation by just writing logs on both sides. Log of 2 to the 3x equals log of 1 over 11. And because of my properties of logarithms, I know that whenever the argument of my logarithm has an exponent, I can remove that exponent and shift it as a coefficient of the entire logarithm. It'll look like this. 3x times log of 2, we can now say is equal to log of 1 over 11. Okay, we've done some rearranging and we no longer have an exponent with a variable in it. Much better. I can start canceling using some of my Algebra 1 skills now. Again, I see some multiplication that I can undo. This 3x needs to be isolated, so I'm going to divide both sides by log 2, leaving me with 3x equals log of 1 over 11 all over log 2. Okay, getting even closer to isolating the variable. Now it's just got this coefficient of 3. So again, I can divide both sides by 3, canceling that 3 on the left, leaving with just x, which equals log of 1 over 11, all divided by log of 2. And where do we put that 3? Well, since we're dividing by 3, we can just put it at the bottom of our fraction. I'm going to put it over here just so that my calculator doesn't confuse it as part of the argument. I'm not saying log of 2 times 3. I'm saying 3 times log of 2, or log of 2 times 3. This is the clearest way that most calculators should be able to read it. And here on Desmos, it understands what I've now input. You don't need this x equals part. In fact, if we delete it, it doesn't change at all over here. My final answer is negative 1.153143873. But we should round that. How precise did we want to be? To the nearest hundredth. So I can notice that I've got this negative 1.15. I can cut off the rest. That 3 didn't change too much. So I'll leave my answer as negative 1.15 and submit. Excellent. So let's recap the steps that we did. First, we copied the equation down into our workspace. We divided both sides of the equation by this coefficient. We shifted this 11 from the left side to the bottom of the right, on the right side in the bottom of the fraction. We then rewrote the equation using logs as prefixes to both of these sides of the equation. Because we now have logarithms, we can use some rules of logarithms to shift this 3x exponent in front into a coefficient. So this 3x goes from the exponent all the way over here to a coefficient. We've got a bunch of multiplying going on, so we can do some canceling with division. First, I divided both sides by log 2, putting the log 2 in the bottom right of this whole expression. The 3 needs to be divided away as well, so I also put it in the bottom of this expression. Since they had the same priority, the 3 and the log 2, they get to stay down here. We don't need an extra fraction bar. I found what it was equal to, and I rounded appropriately. Let's do one more example. Solve for x, rounding to the nearest hundredth. 32 times 2 to the x over 5 equals 16. Okay, let's do it. I'm copying my original equation into my workspace. 32 times 2 to the, again, it's a complex exponent. I'm going to use some parentheses. Some of these problems might have simple exponents, but I've just been lucky. Okay, and all of that should equal 16. Next line of work. I have this 32 coefficient that I can divide. So I'm going to just take 2 to the x over 5 equals 16 over 32. Now, you might notice that that can be simplified, but not every problem will be so obviously simplifiable, so I'm just going to leave it like that for now. This is the step where my logarithms come in. I have a base and an exponent, and I want to get this variable out of the exponent, so I can start off by using logs. Log of 2 to the x over 5 equals log of 16 over 32. Moving on, I can now take this exponent in this log expression and rewrite it as the coefficient. Now that's x over 5 times log 2 equals log of 16 over 32. Okay, let's keep going with some canceling. I can now cancel this log 2, leaving me with x over 5 equals log of 16 over 32. All of that is over log 2. Super. Now it's just x over 5 equals log 16 over 32 over log 2. I just need to cancel this over 5. Well, since it's dividing by 5 on the left, I can just multiply both sides of the equation by 5. So my next line, I cancel this 5 by putting it into the right side of the equation. But where do I put it this time? Last time we had a coefficient that was being multiplied, so we put it on the bottom on the right. Here, we're dividing by 5 on the left, so we'll put it on the top of the right. So how about I just put it in here? 5 times log of 16 over 32 over log of 2. And all of that simplifies to negative 5. I'm going to go ahead and write that in here. Fantastic. So once again, the steps. Copy the original problem into your workspace. Cancel a coefficient by dividing by both sides. It'll look like you just shifted it from the left to the bottom of the right. Then rewrite this equation by sticking logs into the front of both sides, and rewrite again using this exponent that gets shifted to being a coefficient. Once you've done all this rewriting, it's back to more canceling. This multiply by log of 2 can be canceled by dividing. Again, we shift it to the bottom of the right side. It's a whole new fraction for the log of 2 to be underneath. Then we're left with this divided by 5. We could then think of that as undoing division or multiplying. So I'm going to put that on the top of the right side of my equation, leaving me with just x equals 5 times log of 16 over 32 all over log of 2. Another way that we could have done this is by recognizing some of the simplifying that could have happened earlier on. When I had 32 times 2 to the x over 5 equaling 16, and then I did that first step of dividing, I reached 2 to the x over 5 equals 16 over 32. And this is that simplifying step that I mentioned before. I might recognize that 16 over 32 is the same thing as 1/2. 2 to the x over 5 equals 1/2. And now we might be able to use some of our same base strategies, which we didn't use earlier in the problem. I can recognize that 1/2 is just 2 to the negative 1. Now I have an equation that says 2 to the x over 5 equals 2 to the negative 1. Same base. That is a shortcut strategy that I love to use because it just means that I can erase the base. X over 5 equals negative 1, and then we have a pretty simple problem to do here. We could think of it as cross multiply, or we could just think of it as canceling division. Multiply both sides by 5, and once again, we'll get x equals negative 5. So there are many approaches that you can take. If you notice that you can get same bases, go ahead and use same bases. Otherwise, you can just follow the procedure of canceling, rewriting with logarithms, and canceling some more until you get an expression that your calculator can evaluate. Let me know what your questions are, and good luck.